Okay, factoring trinomials of the form x squared plus bx plus c. Before we start that, let's just go back and look at simplifying these multiplying these binomials. So using FOIL, we get x times x is x squared plus 6x plus 7x plus 42, collecting terms, x squared plus 13x plus 42. Here we have x squared minus 3x minus 5x and plus 15, giving us x squared minus 8x plus 15. And last we have x squared minus 5x plus 12x minus 60, which is x squared plus 7x minus 60. All the above products simplified to trinomials of the form x squared plus bx plus c. How do we go in the opposite direction? That is, how do we take one of these guys and turn it back into this? So we know x squared plus 13x plus 42 factors into x plus 7 times x plus 6, and these two here. If we examine the constant term and the coefficient of the x of the trinomials in simplified form, so these are the constant terms, here, here, and here, and if we look at the x coefficients of the simplified form, then we want to use the relationship. So for example, if x squared plus bx plus c factors into x plus p times x plus q, we know that p times q is equal to pq, and p plus q, or sorry, we want this to be c. P times q, the last term is c, and p plus q will be b. In other words, to factor x squared plus bx plus c, we need to find the two numbers that multiply to c and add to b. So now we're going to go and we're going to factor these. But before we do, I just want to stop and look at something else. When I factor, I look for a pattern of signs, that is the pluses and the minuses. So let's take this, expand this, we get x squared plus 5x plus 2x plus 10, which is x squared plus 7x plus 10. Now, let's do the exact same thing with minus signs. So it'll be x squared minus 5x minus 2x, but still plus 10. And you'll note that what's happening is, for this last term, we're multiplying two positives together to get plus 10, or two negatives together to get plus 10. And our middle term, when the last term is positive, it says basically that both of your signs in your original binomials, or what you're looking to factor to, must be the same sign, right? The only way to get a positive product is to multiply two positives together or two negatives together. And your middle term, the 7 here, the plus 7 or minus 7 will tell you the signs of the original binomials. If this is a plus, the original signs are both positive. If this is a minus, the original signs are both negative, right? Again, when we have a final positive term. So we're looking for two numbers that multiply to 10 and add to 7. They're both the same sign. This case tells us they're both positive, and this tells us they're both negative. Okay, let's do the same. Let's go x minus 2x plus 5. So we have opposite signs. This will give us x squared plus 5x minus 2x minus 10. So this time you note our final term is negative. We get x squared plus 3x minus 10. And let's do the same thing, but this time have a plus 2 and a minus 5. X squared minus 5x plus 2x minus 10, which is equal to x squared minus 3x minus 10. Now you note, when we have the last term negative, that means that our original binomials, we had a positive and a negative. The only way to get a negative product is to multiply positive times a negative. So when you see this minus sign, you know that they're opposite signs. Now in this case, the numbers multiply to 10, but they don't add to 3, they differ by 3. Okay, they differ by 3, and this sign is the sign of the larger number. So if it's a plus 3, then we know the larger number is plus, and if it's minus 3, then we know the larger of 2 and 5 is a minus. So when I'm factoring, I'm going to look at the last term and figure out if it's positive or negative. If it's positive, I want two numbers that multiply to the last term and add to, whose sum is the middle term. And if it's negative, I want two numbers that multiply to this, but which differ by, whose difference is the middle term. Okay, let's go back to the Word document and continue on. Okay, A. So I have a positive, which tells me both terms are the same sign, and this is positive, so they're both plus. So I can immediately write this down, x plus, Two numbers that multiply to 28 and add up to 11 are 7 and 4. Okay, doesn't matter what order you put them in. There we go. I have a minus 20, so I know that I have one positive factor, one negative. Two numbers that multiply to 20 and that differ by 3. They don't add up to 3, they differ. Well, okay, what multiplies to 20? 1 times 20, they differ by 19. 2 and 10, they differ by 7. 4 and 5, they differ by 1. So this is not factorable. Okay, we cannot factor this. For this one, let's rewrite this. B squared minus 5b minus 24. Okay, I like to have the b up front. I want the variable that's squared up front. Okay, so I know this will be b plus and b minus. Two numbers that multiply to 24, that's negative, so they differ by 5. The numbers are 8 and 3. The larger number is negative, so the 8 goes here, the 3 goes here. Now when you check, just do a quick FOIL. B squared minus 8b plus 3b is minus 5b minus 24. And I forgot to do that here. X squared plus 7x plus 4x is plus 11x plus 28. Okay, let's go down here. I have an x. I'm also going to have a y. The negative sign tells me that we're going to have some number in front of the y. So I'm going to go x plus some y, x minus, and again, some value of y. Two numbers that multiply to 54 and differ by 3. Those numbers are 9, and 6. The larger number is negative in order to get that negative, so this will be minus 9y and plus 6y. Let's FOIL it out to check. Just do this mentally. X squared minus 9xy plus 6xy is negative 3xy minus 54y squared. Okay, next one. Oh, we've got a t in each term, but we also have a 4. So we're going to common factor a negative 4t out, giving us t squared plus 4t, right? This is how I'm going to get the negative 16. And this will be minus 32. 2, and I've had to change the signs, right? So all of the signs, this was negative, this was negative, this was positive, they're going to switch signs because I've taken a negative out. Okay, so we write negative 4t. That always stays as one of the factors. This is a negative, so I have a t plus, and I have a t minus. Two numbers that multiply to 32 and differ by 4. Okay, 1 and 32, no. 2 and 16, no. 3, 4 and 8, yes, 4 and 8 will work. The larger number must be positive. This middle term is positive, so we need a plus 8 and a minus 4. Check it out, t squared minus 4t plus 8t is plus 4t minus 32. Okay, last one. Let's squeeze some space in here. Again, we have a common factor. 5 goes into everything. There's a p, at least a p in each of these, and again, at least a q. So 5pq. Our first step is always common factoring. Okay, I've already got the 5 and the q, so I need a p squared plus, I've already got a p and a q, so plus pq minus 20, and I've already got the p, so this will be q squared. Okay, so 5pq, got to keep that as a factor. This will be a p, again that's a minus, so I've got a p plus some q. We're going to fill that in, and I've got a p minus some q again. And what are those numbers? Well, they multiply to 20. Because of the minus, they differ by 1. That's 5 and 4. The larger number is positive, so 5q, 4q. Try it out. P squared minus 4pq plus 5pq is plus 1pq minus 20q squared. Okay, keep going. What do we have? Well, in this case, we have the square of a binomial, and then the same binomial appears. So let's solve a simpler problem. Let's let a equal x minus 3. Then wherever we see x minus 3, we're going to replace it with a. Gives us a squared minus 8a plus 15. Okay, let's factor that. That's a plus, so they're both the same sign, and they are in fact both negative. I need two numbers that multiply to 15 and add 2, because that's a plus, add up to 8. Numbers will be 3 and 5. Doesn't matter where they go. But we're not really done here. What we've done is we've factored the simpler form, so now we have to go back and replace the a with an x minus 3. So x minus 3 minus 3 and x minus 3 minus 5 gives me x minus 3 minus 3 is x minus 6, and x minus 3 minus 5 is x minus 8. And that is the complete factorization. In order to show that these two are the same, we would actually have to expand this out, collect all of these together, multiply these, and show that they were equal, which I'm not going to do. Okay, on the next one, we have the same idea, right? I've got the square of something minus 1 times that same thing minus 6. So let z equal 2a minus 1, which gives me something of the form z squared minus z minus 6 to factor. Okay, we've got a minus, so that means that we have opposite signs, z plus, z minus, multiply to 6, differ by 1. Those are 3 and 2. Larger one, the 3, is negative. Wasn't really a z though, right? It was. So I'm going to put it leads to. It's not really equal to. So 2a minus 1 plus 2 and 2a minus 1 minus 3. And that's equal to 2a plus 1 and 2a minus 4. Again, that's the simplified factored form, except, wait a second, there's a common factor inside here of 2. So I need to take that out. So there's a factor of 2. We've got the 2a plus 1, and dividing this by 2, we get a minus 2. And now we are in fully factored form. Okay, so we can't leave even a binomial factor that can still be factored. So this is the fully factored form. Multiplying this out, doing the binomials first, then multiplying by 2, will give us the same result as if we expand this. Okay, a few more. So here we have probably need two numbers that multiply to 18. It's positive 18. They're going to have the same sign. Okay, so x plus 1, x plus 18. Okay, that will work. That will give us a k value. We'll get x squared plus 18x plus 1x. So that'll give us a k value of 19. Okay, we could have x minus 1, x minus 18. Again, we want to get a positive 18. That gives a k value of negative 19. We could have x plus 2. So all we're really doing is running through all of the factors of 18, 2 and 9. Whoops, and that gives us k. Okay, x squared plus 9x plus 2x is plus 11x. K is 11. Minus 2 and minus 9. So k will be negative 11. What else? We've got 1 and 18, 2 and 9, then 3 and 6. And we know the factors are the same sign to get a positive 18. And x minus 3, x minus 6 will give us a k value of negative 9. So what's k? K is plus or minus 9, plus or minus 11, plus or minus 19. Right, so we have 6 values of k, any one of which we put in here will give us a factorable trinomial. Okay, x squared plus kx minus 8. I need two numbers that multiply to 8. One is positive and one is negative. So x squared minus 8x plus 1x will be minus 7x. That'll give us k is negative 7. We can do the same thing but with the opposite signs. X squared plus 8x minus 1x is plus 7x minus 8. Okay, the important thing is that these two multiply to negative 8. So k is 7. What else multiplies to 8? Well, how about 2 and 4? And they have to have opposite signs. This will give us k is negative 2. X minus 2, x plus 4. Again, these multiply to negative 8. And they have to have opposite signs. There's nothing else that will factor, no other factors of 8. 1 and 8, 2 and 4. After that, we're saying 4 and 2. We've already dealt with those factors. So k can be plus or minus 2 and plus or minus 7. Okay, last one comes. Okay, find a positive and a negative integer value of k so that x squared plus 5x plus k can be factored. And how many values of k are possible? All right, what do I need? I need two numbers that add up to 5, positive 5. So simple one, how about x plus 3, x plus 2? That'll give me x squared plus 2x plus 3x is 5x and plus 6, right? So that equals x squared plus 5x plus 6. So k is equal to 6. What else? How about 1 and 4? X plus 1, x plus 4 gives me x squared. Okay, x squared plus 4x plus 1x is plus 5x plus 4, in which case k will equal 4. X plus 12, x minus 7, x squared minus 7x plus 12x gives me plus 5x minus 84. So k is equal to negative 84. You can see I could keep going on forever, right? As long as these two numbers differ by 5 or add up to 5, then we're going to get a 5x. And they either have to be positive. I can't have two negatives because that would add up to a negative number here. But I can have a positive and a negative as long as they differ by 5 and the larger one is positive, or just two numbers that add up to 5. So there are infinitely many possible values for k. And that's the end of the worksheet.